All right, let's get started with chapter 3, 3.1, algebraic expressions. So there are different parts of an expression. An expression just doesn't have an equal sign. So that means that there's going to be letters involved. However, we don't know what the letter equals, so it's just a placeholder. So we don't know what 7 is multiplying by here, but we do know that some number will exist in this spot. But we won't figure out what that number is until chapter 4. So there are 3 parts. We have variable terms, coefficients, and constant terms. Variable terms would be the terms with the variable. This just means with the letter. So if it helps, I would write letter above variable. So I'm going to circle all the ones that have a letter. So 7x, 5x, and 4x. The coefficients are the numbers that are being multiplied by that letter. So in this case, 7 is a coefficient, 5 is a coefficient, and 4 is a coefficient. Because remember, multiplication just means it's next to each other. We don't put the dot there because mathematicians are lazy. So our coefficients would be 7, 5, and 4. So constants, I'm going to box these in. Constants are the numbers that don't have a letter. And you'll notice whenever I was boxing them in, I include the sign in front of it because that is telling me it's a positive 3, it's a positive 8, it's a positive 1. So 3, 8, 1. So now we need to identify the coefficients of something that just has a letter. So whenever you have just an x, let's skip to this one. So just an x, this is saying that technically there is a 1 in front of that x. But we know that 1 times anything is just that thing. So mathematicians write it as just x because they're too lazy to write a 1 there. It's a thing. So when we have a negative x, what that's saying is we're actually multiplying negative 1 times x. But instead of writing that 1 in the multiplication sign, we again are lazy and we just put negative x. So let's understand what are like terms. Like terms have exactly, and that's super important, exactly the same variable. That is some rough handwriting, but it is what it is. This one is supposed to be an R, but variable. You know what? Let's just try again. variable. Well, it'll do. And/or the same non-variable, which means that it's just a constant. So examples of this would be like y and 3y. They both have the letter y, so they're the same. Or just 3 and 4. They both don't have a letter, so they're the same. Think of Skittles and M&Ms. You don't want to mix the two when you're eating them. They are different. Yes, they might be the same color when you do eat them, but those oranges will taste very different. So example 1, identify the terms and like terms in each expression below. So a term is just the individual number or variable in the expression. This is separated by an addition or subtraction sign. So my terms would be 9x -2, because remember we use the sign in front to like call it the sign of the number. +7 and -x, which is the same as -1x. So my like terms, and this is where I box and circle. I always box and circle the ones that are alike, so that way it helps me later. So my like terms, 9 is alike to negative, or 9x is alike to -x. And then -2 is alike to 7, because they both don't have a letter, and then these two both have the same letter. All right, so let's look at B. So my terms are separated by an addition and subtraction sign. So I have y squared, 5y, -3y squared, and just 1y. My like terms, and this is where it kind of gets tricky sometimes. My like terms in this case, my y squareds go together because they have to be the exact same. So my letter and the exponent have to be the same. And then just my y's are the same. So my like terms, I have y squared, and that's alike to -3y squared. So those are like my Skittles. And then my other set of like terms are 5y and just y. And that's because they only have a y. They don't have anything else attached to it. So just 5y and y are alike, and just y squared and -y squared are alike. A negative and a positive can still be alike if they have the same letter attached. All right, so we're going to skip C, and you are going to go and do A and B on your own. And then when you're all done, you're going to hit play, and you're going to check your answers with mine. So go ahead and go do it. Okay, so I have 3 terms because there's 3 separated by addition and subtraction. So I have y, +10, and then negative, because we include the subtraction as the negative. So -3/2 y. In this case, these two are the only ones that have a matching anything. So I only have one set of like terms. So I have y and -3/2 y. And that's it. 10 is that random M&M in there. Does not belong. Over here we have 4 terms. So 2r squared, 7r, -r squared, and -9. I only have one set of like terms because the r on with my 7 doesn't have a squared attached to it, so it makes it different. They are not the same. Because remember, a squared just means you're multiplying that thing twice. So it would be like having 2r, 7r, and -r. So these two both have r attached. I sound like a pirate. Moving on. Okay. Combining like terms. You can simplify an algebraic expression by combining like terms. This means to combine common variable terms and constant terms. An algebraic expression is in simplest form when it has no like terms and no parentheses. So we're going to simplify this one right here. So we are going to box and circle. So box in everything that has an x and include the sign in front of it. See how I included that negative? I'm including that positive. And the 7 we know is positive, or else there would have been a negative in front of it. So we have 7x minus 5x plus 4x. Now you cannot type in a letter on a calculator. I know that my calculators have letters on them. It is not the same. So do not do it. However, you can still use a calculator. So we would just type in 7 minus 5 plus 4. 7 minus 5 plus 4. So that gives us 6, and then we just keep the x. attached to it. So 7 minus 5 is 2, plus 4 is 6, and then keep the x. Then we're going to go over and circle everything without a letter. So I have 3 plus 8 minus 1. 3 plus 8 is 11, minus 1 is 10. You can check that on the calculator if you wanted to. It equals 10. So now when I write my answer, and you type this whole thing into Big Ideas, you would type 6x plus 10. And we know it's plus 10 because this was a positive 10. And that goes into Big Ideas. The whole thing, 6x plus 10. Don't combine them. We can't combine our Skittles with our M&Ms. 6x plus 10, type that in. Okay, next one. We're only going to do a few of these. So over here we have 6n, and then we have a negative 10n. They both have an n, so you're going to do 6n minus 10n. So these, remember we do keep, change, change. So different signs mean that we subtract. 10 minus 6 is 4. Keep my letter, and then it'll be negative because my bigger number is negative. Again, if you don't remember those rules, you can go over to your calculator. 6 minus 10 is negative 4. We can do it with decimals as well. So these all have a W attached to them. So these are all like terms. So we can combine all of them. So negative 8.5 plus 5.2 plus, remember, it's 1W. So we have negative 8.5 plus 5.2 plus 1 gives me negative 2.3W. I want you to do this one and this one on your own, and then you will check your answers with mine. All right, so over here we have 7m minus 5m minus 6. My m's can be combined because they both have an m. 7 minus 5 is 2. Keep my m on there. And then the 6, I can't combine it with anything because it doesn't have a letter, so I just bring it to the bottom and I attach it. So this whole thing is my answer. So over here, I have 26x plus 2y minus 4x plus 10y. So my x's can be combined. 26x minus 4x is 22x. 2y plus 10y is 12y. And then I just write them together. 22x plus 2y. And that whole thing is my answer.